All right, let's get started, guys. Yay, another week of Star Trek. We're carrying on. Congratulations to all the writers and the crew and everyone for renewing season 2. Super exciting, super excited about it. Hey, how's it going? It's Edan. Good to see you. We can jump right in. This is probably only going to be about half an hour, actually, just because there wasn't a ton of science in the last episode, but that's okay. It was a great episode by all accounts. The only thing for me is that I'm a fan of the L word, and there's a notorious character from the L Word who showed up as Amanda, and of course Jenny would be immortal and eventually marry Vulcan. So thoughts. Carrying on. All right, so we're going to jump right in. There's just a couple of things that we're going to talk about, but there's some good stuff that went on in this episode. So first thing to talk about, we see Vulcan, which looked awesome, by the way. Special effects for that were amazing. Super duper pleased with that. So really happy to see that. And then Sarek took off with his weird Vulcan buddy, and vertical liftoff. Woohoo! This is a thing that we do and that we see. The military uses vertical takeoff all the time. SpaceX, because of course they are trying to develop more vertical takeoff capabilities for other people to be able to do. But we're not quite to the point where it's actually feasible yet. But the technology exists, so that's pretty cool. And it's always fun to see, even if it's all special effects. It's awesome. Okay, so the other stuff that we're going to get to... wrote in the wrong one. There we go. Make sure that stays paused. Maybe. Yeah, we're good. I think we're good. All right. Jogging through a spaceship. I love jogging through a spaceship. I think this is kind of a shout out to a lot of famous sci-fi episodes and things like that. The first obvious one is 2001 Space Odyssey, when they have the artificial gravity with the spinning spaceship and he's jogging through the ship. It's a really iconic scene in science fiction. So I felt like that was kind of a cool shout out to that, because Battlestar Galactica did that as well, with Starbuck in the opening pilot. Jogging through the ship, wearing cool disco shirts. I think there's a plan forming for some disco shirts to make their way to Dragon Con, so that's awesome. It's all warming on me, which is pretty cool. So anyway, jogging through spaceship, artificial gravity. We talk a lot about how in 2001 Space Odyssey, they use artificial gravity in order, or they cause artificial gravity by rotating the spaceship, and that's how he's able to jog, and that's how you get that cool effect. And one of the things I always like to say is that, the Enterprise isn't super round, Discovery isn't super round, so how do they have artificial gravity on Star Trek ships? Excellent question. It's not from rotation, as much as we would hope that it would be. They use timey-wimey, wibbly-wobbly stuff. Mostly it comes from, I think, dilithium crystals, and from also they have superconductors that generate the artificial gravity, at least in the bowels of the 1701D, if I remember the technical manual correctly. But it's not rotational artificial gravity like we see in The Martian or in 2001 Space Odyssey. So carrying on from there, I desperately wanted to talk about this. And then I went to do some research about this. So for those of you who don't remember or are for some reason not watching Discovery and just watching this, okay. This scene, right? He injects himself with something, basically says he's one of this faction that hates humans, kill all humans type attitude. And injects himself, and then slowly, while he's having his moment explaining this all to Sarek, starts to go on fire and starts to explode. And I was like, I wonder how you could do that. And then I started typing into Google things like not stuff that you want to type into Google unless you want to visit from the FBI. I don't know enough about chemistry and biology to type something sensible into school that won't get, or into Google that won't get me on a list somewhere. Basically, for just problem solving, in case anyone else has more guts than I do in terms of trying to figure out how this would actually work. I'm trying to figure out if there's some sort of chemical that would interact with, okay, pretend human, interact with the iron in blood or water, or anything that would have a slow burn effect like that. Now the problem is that Vulcans obviously bleed green. Is the color of their blood. It's green, right? Not blue. No, it's green. So what causes that? Now, our blood looks red because the iron oxidizing with the air, I think. Yes, green. Thanks. Yeah, Vulcans have different makeup, and I imagine there's some chemical that whatever chemical is in Vulcan blood, you could have a slow burn chemical catalyst reaction that would kablooey. And yeah, but I haven't thought of a good Google search to do for that won't get me on a list. So carrying on, we can talk about that at another time. As he's about to explode and Sarek pieces together what's going on, he throws up some shields around him, and then this gets torn out of warp and goes flying, and things to discuss. Okay, so first of all, how did Sarek save himself? What did he throw up? It looked like a shield for a brief second. For those of you who don't know, I get these clips by screenshotting as I'm watching it, because if you pause it, the screen goes shunk. And so I have to do it all live. Hope that I get a good one. And as much as I tried, I could not get a good shot of whatever shields Sarek threw up in there. So I'm rewatched it a bunch of times, and I'm still not totally sure if he just threw a shield up around himself or if he isolated the other Vulcan from the ship, which I think seems more likely given what happened after the fact. Like, the ship's disabled, but he's like able to lie on the ground and survive. Like, he's not vacuumed into space. He's not transported anywhere or anything like that. So we're gonna go with he somehow was able to throw up a shield around this dude. Yeah, is it possible with their tech? I don't know, and I'm not sure. The 48 hours I give myself to put this together didn't allow for me to have time to sort this out. Because, so if we place where all of this is, right? This is 10 years before the original series. Oh, hey, Reef. Why wasn't he vacuumed into space? Yes. So, if we're thinking like 10 years before the original series, then they obviously have cloaking technology, because the Klingons are talking about trading that and getting that technology able to put on their ships. Now, is it possible with their tech? We need to sort out how much the Vulcans and humans are actually talking to each other at this point, because the timeline's all a bit hooey, right? So Spock is like a kid, but by the time this is airing, he's already decided to go to Starfleet. And where was I going with that? Oh, and the other thing was that there was the episode, I think it was the first or second, I think it was the second episode, that first war, yeah, where she's in the brig, and the stuff tears through the ship, and the shields go up. Like, remember, the whole side of the ship is torn out, and her, like, cell is all shielded off automatically. I think for this, they're assuming that it's the same technology. So we're going to ignore, for now, how much the Vulcans and the humans are actually communicating and sharing technology, because there's obviously a huge faction of Vulcans that don't want to interact with the humans, but that's always been the case. So we don't know kind of the realm of that. So let's imagine that what Sarek was able to do with a punch of a button was to throw up a shield and isolate the bad guy from the ship. And then when he exploded, it built one of these shields like it did around Michael in episode 2. So the ship was like totally protected from that. Why he's... Yeah, so, yeah, it explains why he's not vacuumed, but what he does to defend himself. Exactly. So I think that's the case. We're going to go with it because we're just going to assume that they have the same shield technology. So we're good with that. Now, the next thing in this scene that we need to talk about is the idea that half your ship blows up while you're at warp speed. A rut-row. That's not ideal. And what happens to your ship when that happens? This has actually been discussed a lot. I'm going to name drop, just freaking forgive me. Just know that I'm slightly ashamed of name dropping right now, but not too ashamed to not do it. So Rick Sternbach, who was a kind of artist designer for most of like Next Generation, Voyager, Deep Space Nine, like that era, I met him at a convention once and told him about what I do, and then we geeked out for a little while. And one of the things that we talked about is what happens if, like, let's picture the Enterprise, not this ship, but the Enterprise that has the two nacelles and the one blows up, what would happen? And Rick was saying when he first designed these ships, the problem is that would literally like tear your ship apart. Not great. And so he designed some sort of like fail-safe that I think is in the technical manual where ships are able to compensate for that. Now, compensators are a great Star Trek technobabble that we use to say, that's how we make that work. And we're going to assume that something similar happens here. So what would the have to be, whatever compensators those are? And I'm sorry, I don't remember exactly what it was. I'll try to do some research and put it on Twitter or something. But let me see. I think I put a picture in here. Again. Yeah, so saw this. I stole this off the internets. I've seen this everywhere. I can't find the original source. If anyone has the original source, please send them to me so I can thank them for using them in all of my talks. But this is kind of an image of how warp drive works, right? It's the idea that you compress space-time in front of you, you extend it in the back of you, and then you basically create this bubble. Now, why do you do this? Because normal space-time, you can't go faster than the speed of light. And nothing precludes space-time itself from going faster than the speed of light. It can go whatever speed it wants. It's just things that are on space-time can't. And so how warp drive works is that you bend it and you basically create, like, I describe it like an onion or a parfait or something with layers. In Star Trek, what they do is they say, all right, we compress it in the front, extend it in the back. And so we have just this little bubble that goes around you that you can kind of, just do it this way, propel yourself through space-time faster than the speed of light. Now, yeah, excuse that right there. That explains why this ship seems to extend exactly. Bingo. So... yeah, it said that explains why the ship seems to extend its back when it goes into warp. Hooray! Correct. And yeah, it's super useful. And now, so we have the different stages of warp when they talk about warp 2, 3, 4, 5, 6. Not warp 10 because terrible episodes happen. You are basically, you have your bubble like that's compressing you. I cannot do this mirror camera thing. And then you build another bubble on top of that one. So you have one that's doing this, and then you have one on top that's doing that, and you add in all these layers of warp in order to go faster and faster and faster. That's how I interpret it. Now, what would happen if suddenly half of that bubble just went... Basically, what would happen is that you have your whole bubble, and then half of it would just immediately go... Okay. First of all, gravitational waves would happen. So I hope that this will result in me getting a job in Starfleet one day, being able to explain the risk of gravitational waves from ships dropping out of warp unexpectedly. But literally what would happen is your bubble would start to collapse, which means that compressed bit in front and the stretched out bit in back would all start to even out. So that would start to stretch out this way. This would start to compress the other way. And somehow, we're imagining if you have the technology to bend space-time around your ship, you probably have the technology to compensate for this sort of thing. So if there's like this catastrophic loss of your warp bubble, bad things would happen, but it wouldn't be as terrible as you would think. Now, what you would need the ship to do is have some sort of compensator set up in it so you wouldn't have it all stretch out with space-time. Basically, it would have to internally warp space-time to compensate for it. Now, this is going to get really complicated. That's sort of how I view it. I think it's legitimate. I've thought about this a lot. Now, things like explosions and how quickly you'd be able to respond to that is a little harder. And I also have to go back and read the technical manual in order to do this. I read when I go out on like Sundays and I go to bars and I read, and getting caught reading the technical manual by yourself at a bar, that's my image. But I do it anyway. All right, so when we're talking about dropping out of warp like this, what happened to Sarek's ship, you saw it all pulled out of warp at once. And now, so what you can do is you protect your ship one way, you protect your ship the other way, and basically you just want to so you have one that's totally flat and compressed and this other one, and your ship is in the middle trying to keep it all even. And so what you would want to do is even out, because you have control over this part. You don't have control over this. This is flattened out. And so what you want to do is slowly, as slowly as physically possible, science fiction, even out space-time on your bubble, but that drops you out of warp. So you protect your ship, but you drop out of warp, just like we saw here. Now, he ended up in a nebula, and I do have some cool things to talk about that. So the Discovery got here. I love the little ringy disc part, by the way. I really like that. I think visually it's super cool. And they end up in this awesome, weird nebula. Vuroth has followed. Thank you. I appreciate it. They end up in this weird, cool, pretty nebula, right? And they're trying to find Sarek. And they don't know where he is, and they can't scan for him. And we had this problem in the first episode when they were trying to scan for whatever it was that was, it turned out to be the Klingon ship, but they couldn't because of the radiation fields. And it's the same here. So nebula in space science basically just means cloud of dust and gas. It comes from Greek, and space science has just appropriated any sort of dust or gas cloud to be a nebula. Now, we have all different sorts of ones. So you may have heard of planetary nebulas. Those are very misleading. The reason they're called planetary nebulas is because when astronomers first were able to see them in telescopes, they looked like planets. So they do look like Jupiter or gas giants, but they're really far away. So they looked like planets, but they weren't. They turned out to be gas and dust that were left over from when a star, a sort of mid-range average star, died. So like our sun is going to do, it's just going to go... And we'll just get a lot of nice, pretty dust and gas from that. And that's what our sun will do, and that's a planetary nebula. Now, they don't say what kind of nebula this is, but that's okay. The other types we have are as stars are being born. So that's what we were talking about last time. There's lots of types. Any just clouds of dust and gas are out there. So they end up in this nebula, and we don't totally know what kind it is, but that's okay. Basically, you have a lot of ionized gas. So nebulas can be warm, They can be cool or warm or somewhere in between. Again, based on where they are in their life cycle. If they are forming a star, then they're going to get really warm. Again, just from friction. All that dust and gas is going to heat up. Or, you know, it's going to be cooling off as the cloud dissipates, and then it will all gather together and make a new star. Circle of life. Circle of life of stars. And yeah, so they end up at this nebula and they can't detect through this radiation field. Totally valid, because you would have pockets of ionized gas, which is going to be throwing off your sensors. Now, again, I've talked about this a little bit before. I think I caught it in there. Yeah, where their scanners inoperative. Basically, if they're trying to search for something in a nebula, and you can watch my first episode on this to go more into it from the premiere. But if they're searching for someone, they're going to be doing what is called active sensing, which means they're poking at the radiation field and seeing what comes back at them if they're looking for something. So it's called active sensing, and you're going to be using the electromagnetic field, electromagnetic radiation of some sort. So, you know, could be radio, X-ray, microwave, whatever. Now, the higher you go, when you start going into ultraviolet, X-rays, gamma rays, those sort of things, the problem is that you start to have a lot of energy. And so if you have high energy electromagnetic radiation hitting gas, you're going to be ionizing it further, and you're just kind of screwing up your whole sensor. So when stuff gets ionized, that means electrons fly off of it, and it gets hard to detect things through that. It's a really simple explanation, but I hope that makes sense. That's why detecting things in a gas cloud would be difficult in space, legitimately difficult. Now, we are able to look at nebulas from Earth because we do more passive sensing. So what's going on is that the nebulas in space are, again, slightly warm because of friction, and electrons will be kind of pinging off, or things are running into each other. And when they ping off, they give out radiation. So that's the pretty colors that you see. And we just see that passively because we just have our telescopes open, and then any electromagnetic radiation hitting those telescopes from the nebula, we'd be able to detect. So those are the two types, passive and active. You can see the nebula because it's coming at you. The radiation from it is coming at you, but you can't look into it for something because that requires poking it with electromagnetic radiation, which is difficult. So we can't look for Sarek in here. Womp womp. That's difficult. Not ideal. So, like I said, this is actually going to be a really short episode because there wasn't a ton of science in here, as a great an episode as it was. So I apologize. But the last thing I kind of wanted to talk about was this was the picture of the nebula. Ooh, pretty shiny. Remember they had to send the shuttle in there because there were two problems. One, they couldn't scan through, so they couldn't find Sarek, but they also couldn't send the ship in because they said that the radiation from the nebula, I wrote this down, the radiation from the nebula would interfere with the spores, our best friends, the spores, and cause kablooey to happen. How legitimate is that? Better than you'd think, actually, when I started looking at this. Yes, they would interact with the spores. Better than you would think. So, again, I've only watched this episode twice. I have not torn it apart as much as I could. So if I missed a line of dialogue that screws up this whole thing, I humbly apologize, and you can correct me kindly and nicely because we're all friends here. But please forgive me. But the way I interpreted it was they didn't want to go in there because the radiation from the nebula would interact with the spores in a not so great way. Now, if you look at this picture, this doesn't quite look like nebulas. If you have a fondness for Hubble photos, this doesn't totally look like nebulas that we look at, or that maybe we've seen in other sci-fi. It's very colorful. So what do we see in here? We see some blue, we see some green, and we see some red, and a little bit of yellow too. And the thing I like about this is if you look at this picture, which is a picture from a nebula, this is a Hubble image of the Carina Nebula, which is a star birth nebula. So stars are forming in here. So it's really hot. The brown, darky, swirly bits are dust. So we're not able to see the light from that. And you see all these cool, I mean, this is huge scales, light year scales here. But it's really warm because stars are forming in here. And all that radiation that's coming off the forming stars is heating up the other gas particles. So even if they're not in the process of becoming stars, they're getting heated up because of the radiation from the stars. And, but Hubble images are taken in the optical wavelength. So what our eyes would see over a long period of time. So you can kind of imagine if you went outside just now or all the lights went off, it would be dark, but then it'd be like pitch black. But then the longer you waited, you would start to pick up some lights here and there. Now that's your eyes adjusting, but Hubble kind of works in a similar way, just in the sense that it'll stare in a region that initially looks dark. If it just looked and then looked somewhere else, we would get nothing. But it looks and it just stares and it waits for light to add up and come to it. And basically you just get 1 or 2 photons off of things like this, and it just slowly adds up and you piece together this picture. So kind of cool, maybe a little weird if you've never learned about that before. It can sort of be weird to wrap your head around, but still cool. And but what they do is Hubble detects in multiple wavelengths, and so we have what our eyes would see, but then we also are able to sort of isolate spectrum. So yeah, like photography. Thanks, it's CDAN. Yeah, like photography. You open the exposure for a long time. It's a photo. I mean, it's a camera in space looking at space things in space. And you leave it there and you stare. But in most of astronomy, we're doing spectroscopy, which means that hydrogen will emit at a certain wavelength. Again, remember I said those electrons kind of fly off. When they fly off, they emit a certain wavelength. So you get like one spike of color, and then you get another spike of color and another spike of color. And you can kind of enhance those colors, which is what they do in this imagery. Now, I promise I'm getting to the fun stuff. I said this would be half an hour. This is all it's going to be. In this picture, what they have is red is sulfur, green is hydrogen, blue is O2, and the majority of this is light of ionized hydrogen, so hot ionized hydrogen. Now, red is sulfur. Now, we go back here. There's some red in here. We're going to say it's the same concept, and sulfur is used as an antifungal. Science! So if we're going to say that there's a ton of sulfur in this nebula, and sulfur in our world is a anti-fungus, kills fungus, kills spores, then we're good with it. Don't drive the ship in there because the sulfur will kill the spores. I'm going to call that good. I kind of made that up, but I'm happy with it. When I started adding it all together, it kind of worked. I went, what kills fungus or what kills spores? And they were like, sulfur. And I was like, hang on, that's from the Hubble pictures. So yeah, we're going to go with it. And we're pretty happy with it. Thank you. I am glad you appreciate my logic. Oh, thanks, Susie, for following as well. Hi, Eric. We'll talk later about this. I suspect I'm going to get some messages from you. So yeah, anyway, red sulfur in Hubble images, red in images here. Sulfur does bad things to fungus, and we're gonna call that good. Oh, hey Rosa, thanks for joining. Yeah, quick overview what we did. We talked briefly about vertical liftoff. We talked about jogging through ships in science fiction, which is a thing, and artificial gravity. And just shout outs to classic sci-fi. And then we also talked about, we talked about how I wanted to say that I wanted to search for ways that Vulcans could blow themselves up, but then didn't want to end up on an FBI list. So I didn't search for it. Maybe one day. And then we talked about ships exploding and falling out of warp and how that's possible if you're able to compensate for space-time and you just have to fall out of warp and then you're okay. And then we talked about nebulas and how you can't actively sense through nebulas because that's hard because it's ionized. And so you can't search for things. We can get emission from nebulas. And also it was really pretty and there was some red in there, and red and fungus, sulfur and fungus are not good things. I'm good with my logic on that one because I'm not a biologist and I've had to learn so much biology for this freaking show that I'm okay going with that. So anyway, like I said, this is a super short one. We'll call it good here. There wasn't a ton of science in it. But it was a fun episode, and I'll post this later if you weren't able to catch the beginning of it. But thanks for hanging out with me and watching. And I will probably, thank you. I think it was good logic too. I will probably change the time of my stream next week to Wednesday, I think, because it's Halloween and I'm going trick-or-treating. So that's happening. All right. Logic wins. Thanks, Vulcans. Yeah, exactly. Vulcans would be proud of this. All right. Well, thanks for hanging out with me, everyone. It was good to see some friendly faces. And live long and prosper. I'll catch you next time. All right. See ya.